Where is it? Should be live. Come on, where is it? Ah, here we go. What? Okay. It's here. Yes, Whale Tech, I am live, and wow, you joined quickly. Come on, where is it? Good job. Here we go. YouTube should have a thing where, like, someone's name should be colored differently if they, join, they join a stream and then they never miss a stream. I am live. Because I know some people who would have names like that. Come on, where is it? Good job. Here we go. YouTube should have a thing where, like, someone's name should be colored differently if they, need to join, they join a stream and then they never miss a stream. I just turned on my computer and I just have to stream today, so. Where is it? Good job. YouTube should have a thing
Put this
where,
in
like,
picture
someone's
mode.
name should be colored differently if they, need to
Oh, that's
join,
awesome that YouTube's finally notifying
a
people
stream
about
and then
this.
they never miss a stream.
I just turned on my computer and I just have to stream today, so.
Live
chat.
chat. YouTube should have a thing
Put this
where,
in
like,
picture
someone's
mode.
name
Notification.
should be colored differently if they,
Awesome.
need to
Oh, that's
join.
awesome.
YouTube's
Awesome.
finally
That's
notifying a
awesome.
stream and then
Yes,
they never
Whale
miss a
Tech,
stream.
I am
I
live.
just turned on my computer and I just have to
Gonna
click on my DMs though.
YouTube should have a thing
Put this
where, like,
in
someone's name
notification.
Awesome.
Oh, that's
Join.
awesome.
YouTube's finally
That's
notifying a stream
awesome.
and then
Yes,
they never
Whale
miss a
Tech,
stream.
I am
I
live.
just turned on my computer and I just have to click on my DMs.
What I actually came here to do.
YouTube should have a
Live.
Notification.
Awesome.
Oh, that's
awesome.
Or no,
Awesome.
video
Up.
uploads, that's what I want to add. Anywho, what I actually came here to do. What? Mute what?
Whale Tech.
Live.
Awesome.
Oh, that's
Awesome.
Or no, video uploads, that's what I want to add. And is something wrong with my audio? What I actually came here to do. What? Mute what?
Whale Tech.
Live.
Awesome.
Oh, that's awesome.
Or no,
Wait.
video uploads, that's what I want.
What?
to add. And is something wrong with my
Hold
audio?
on, let me check out the stream on my phone, see if I see what you mean.
Whale Tech. Live.
Because I'm not playing any audio or anything. Wait.
Video.
Or wait a second.
That's what I want.
What? Yeah, I know what it is. it should be okay now. As you can see up here, I have my system volume on 5%, so I didn't catch that. Yeah. Something I also got to figure out is my latency settings, so then the stream isn't super delayed, but also so it's still crisp. It shouldn't be too bad on this internet connection. Yeah, there we go. Now it's good. Glad. Live. There we go. I like these faces because they're actually upright. What OS am I running? On this machine, I am running Gen 2. So, ooh. Fast fetch. Gen 2. $1080p isn't that bad, is it? I don't I don't think this monitor is even 4K. I think it's 1080p. Or I could be wrong. Oh, by the way, I got a new monitor because some dick ass broke my old monitor. But I got the monitor from the same company, and the new generation of monitors, and I know this because this isn't my first replacement. I returned the last one because of the same issue, but this new gen of monitors has an issue where it does not work at its rated refresh rate. So like it's rated to work at 165 hertz refresh rate. But I have to set it to 120. Yeah, let's see if I can change my latency settings. Is that something I can do? I'm not sure if that is something I can do. Stream. Frick. Okay, well, okay. I'm not sure if I can change it once the stream starts, but it's fine, right? It's fine. Anyway, I have hook support in my Hyperland Rise for like custom user hooks, and I had to add this to my custom user hooks. Oh, and by the way, back to using Helix because NeoVim is utter dog shit. Yeah, I guess that makes sense that you cannot change latency settings, because what the heck would that look like? Like, would your stream just all of a sudden speed up for people? Hey, welcome. Oh, and guys, for anyone who's had their doubts, yes, I manually send each one of these welcome messages. It's not a bot doing it. I do it. I send these welcome messages. Right. Promotion. Okay, so today I want to work on my CPU ISA. And what I want to do is I want to, oopsie daisy. What I want to do is I want to finish like setting up the stack and the MMU and stuff. So basically, what I've been doing is I've been going and sinning a little bit. I've been asking AI to help me with figuring out how CPU works. Because, like, when I look up these resources myself, what I get is either some really, really shallow YouTube videos or some really, really just overcomplicated papers and stuff. Like, I'm not about to read the x86 ISA just so I can implement, like, so I can understand how stack pointers and stuff are set up. The conclusion I've got is stack pointers, like the base pointer and the stack pointer, are set to 0 by default. Like all the registers are 0 by default, and then the bootloader, or like whatever program the CPU loads first on startup, the bootloader will actually set all the registers to what they need to be. That's the conclusion I've got, and I've been working on my ISA some more, so dev oglo CPU NVIM docs. I'll use NVIM for this. NeoVim, because markdown preview. Alright, so I've been working on my ISA some more. So since the last time I streamed, I think this whole thing is different since the last time I streamed. Basically, I've got every instruction now can have a different can have different arguments for the same instruction. So there's no crap like there's no ladder and no satter. What those were is essentially just load, but the memory address is in a register. That was dumb, so I didn't do that. Also, my ISA no longer, like when you do a jump not zero instruction, what my ISA was doing before is you would do jump not zero, R0, and then whatever memory address is inside, like R15. So if R0 is not 0, jump to R15. And now what you do is you actually use a compare instruction. So you put a compare, so like R0, R1. Essentially what this is saying is subtract R1 from R0. Don't modify any register values, just set CPU flags. And what this is saying is if the compare flag, so basically the result of comparing those two registers, is not 0, so in essence, if the registers do not match, jump to whatever address is in R15. I can also specify an address, so like exit, and boom. So there's that. Another thing I think maybe I forgot to do is if I go to GitLab, Oglo CPU, out of here. Oh, and my ISA, I actually have a build script to build all those instructions into the main isa.md. This is what the ISA MD looks like before I build all the instructions into it. You can see instruction count, ins count, unique opcode count, biggest instruction size in bytes, max ins size, and then over here I have ins tables, which is in the actual text file on the new line, but due to how Markdown displays stuff. And all my instructions are defined like this. And my docs, ASM syntax, I believe I have a thing. Yeah, like I can load the value of like whatever memory address of the label, I can load it as an immediate value into R0. So let me just verify that. What is this? Why is this here? There we go. So, coding, Rust, Oglo, CPU, ASM, Helix, out, test, ASM. So like I can do load R0 exit. And this will load the memory address of exit as an integer into R0. So if I do cargo run assemble -i out test asm -o out test bin. And now let me just verify that works. So if I go here and I go back and I go docs isa load, so loading an integer into a register not a memory address. So not reading memory, but loading an immediate value into register is opcode conveniently 0101. So if I ghex, or actually I can simply just shabby, so shabby dash I elements for, so if I do shabby E for F hex dash I out test bin, okay, something is, oh, right, okay, because I have the copy, that is copy. So down here, 0, 1, 0, 1, 0, 0, so 0, 0, 0, 0, 0, 0, 0, 0, 0. Looks good, and that F there is 15, right? I rust 0xf. Yeah, 15. So that assembled correctly. And then if I change this, so out test ASM, if I change this to say the actual address, and then I assemble this again, and I do that again, I see the opcode has changed successfully. That's good. So, alright, I have that feature, I guess. Oh, and another thing that I did since last time is my CPU is 64-bit now, and 2, it has variable width instructions. And the reason variable... What are you trying to do? Gonna work on my ISA, some assembler stuff, just updating my ISA. And right now I'm just talking about some of the changes that I did to my ISA, so none of you aren't like super lost or anything if you were following since like last time. So my CPU has variable width instructions now. It's 64-bit. And the reason 64-bit is, and the reason variable width instructions is a good thing is because, like, you can see the biggest instruction size in this ISA is 11 bytes. So for every instruction to be 11 bytes, that would be a lot of binary space taken up. Whereas if I have variable width instructions, like the halt instruction, it's only an opcode, so it's only 2 bytes. So that is really useful for just cutting down how much storage space a binary takes. So, yeah. Anywho, what I need to do is I need to figure out the MMU and also how the stack works, kinda. And I feel like I should send an invite link to I don't want to open the DM just because there are some private information in there, but I do not want to, yeah, okay, never mind. Anywho, I need to, this stream is probably going to be kind of a ramble, but I need to flush out the stack. I'm a little concerned because I'm doing this on stream and I am not really familiar with how the stack works. So in my emulator function ins, I need to do. So things I need to do. I need to implement interrupts. So I feel like I need to, in order to do that, in order to implement interrupts, I actually need to allocate a space in memory for an interrupt table or whatever it's called. And then I need to implement calling, which, in order to implement calling, I actually need to implement pushing and popping. And in order to implement pushing and popping, I need to implement a stack. So that is what I gotta do, and I'm really scared about that. Like, I don't know what I'm gonna do. So I believe what I gotta do is when I push to the stack, I could be wrong here. I'm going to use a slightly more based version of ChatGPT to help me. And don't worry, I'm not going to copy and paste code or anything like that. I just need help, because AI is really useful for when you have like these niche issues where resources online, they're either too vague or they're too complicated. So I'm going to ask AI, when I grow the stack, or what happens when I push onto the stack in a CPU? All right. The CPU allocate. Okay, so the CPU allocates memory space on the stack frame. Yep. This typically involves moving the stack pointer down. Okay, yeah. Okay, so let's say like so my registers is good at pointing out in the right direction. Yeah, AI is good for like, yeah, AI is useful for pointing in the right direction, but AI, where I have a problem with AI is when people just start copying and pasting. That is where AI is just, you should not use it for that. So, yes. Also, sorry if I'm like super disoriented and rambly. I literally just woke up. So, yeah. And I haven't streamed in a while or anything. Which, by the way, I hit 3,000 subscribers. Should I do a special? And if I should do a special, what should my special be? SP... BP. And let's say these are allocated at like 100, 100. If I push, int. Yeah, I guess it's, well, here's an actual like technical explanation of AI, but super summarized. AI is just a mathematical function. Like, that's all it is a mathematical function, except it can mutate itself. It can change whatever goes on in it in order to mutate itself and change the result. That is what AI is. It is just a mutating mathematical function. And don't believe me, like, you're wondering, oh, well, how do I pass an image to AI and get text? Well, it's kind of the same thing as like why a computer can handle text and images, even though a computer can only handle bytes and bits. In AI, what you do is when you pass like a handwritten digit as an image to an AI, what you do is you convert that image to some format as numbers. You convert the image to basically a string of numbers representing each pixel, then you pass that to the neural network, and then the neural network spits out some results that you then convert to usable data. So AI is actually quite simple. The complex part is people actually figuring out fancy ways to implement AI to make it faster and stuff. So push int. Hold on, just need to check on recording of mine. Whale tech. Whale tech, I don't know what that means, but yeah, I don't know what that means, whale tech. Okay, so SP minus 8, this will give me 92. So I just shaved off 92 bytes. No, what am I saying? I shaved off 8 bytes. So now SP would be 92. And I would push into, how would this work? Okay, so push the algorithm. It would be decrement SP. And then what next? It would be store value at SP. So then store the value into RAM. So what I'm doing is I'm decrementing downward, and then I'm storing the value at this place in memory. What this is going to do is it's going to store like the first byte at 92, then the next at 9, so 92, 93, 94, 95, 96, 97, 98, 99. Hold on a second. Wait, what? 92, 93, 94, 95, 96, 97, 98, 99. Am I tripping? It should be 100, right? No? 92. Oh. Wait a second. Should I... Okay, now my question is, should I store this value starting at the value that is SP plus 1? So then the last byte is at BP, but the first byte is starting at SP plus 1, or should I store it at SP and it stop, or should I do SP is equal to BP minus 8 minus 8 plus 1, and then store it at SP and it just matches with BP. I'm not sure. Your keyboard sounds nice. Thanks. I have a Cedu V75, and it had really, really ugly keycaps by default, but it still sounded quite nice. My older streams have me using it. But then, and I think this is my first stream with this new keycap set, I changed the keycap set, and now it sounds much nicer, and it looks way nicer. Like, I love the way my keyboard looks. Decrement, store value into RAM. Let's see what the AI has to say. The CPU allocates this typically involves moving the stack pointer SP downwards. The data being pushed is stored in the allocated memory location. In most architectures, this is done using a simple write operation. After storing the data, the stack pointer is decremented. This prepares the stack for future pushes or pops. Right, okay, so software level operations. Context switching. When pushing data onto the stack, it often occurs during function calls or context switches. This allows the CPU to save the current state of execution EIP register update. That's the instruction pointer. In x86 architectures is updated to the point of the next after the call. Yeah. Return address calculation. The return address is calculated based on. Yeah. Well, I know that. Example in assembly. Here's a simplified example of pushing a value into the. Well, okay, not very helpful. Okay, so. In my CPU ISA, integers and pointers are 64-bit, and let's just say that my SP and BP registers are set to the end of memory. Roniel Barrios. Thank you. I'm glad my keyboard is stocky. I wonder if Hippiotech would say the same. Because, like, I consider myself a good ear for keyboards and stuff, but ultimately he is like a real stickler. So if he says your keyboard looks if he says your keyboard sounds nice, it probably sounds really nice. So I wonder what Hippiotech would say. In my CPU, let's just say set to the end of memory. Can you give me an example of what emulator code would look like for the push instruction? Okay, so this is Python code. SP, BP, self registers. Okay, so okay. Setting up the registers push. If self.registers ESP equals 0 out of memory, yeah, makes sense. Value self registers reg name. Oh yeah, so the register you're pushing, and then new SP equals self registers ESP. Okay, yeah, so decrement yes, John Wick. In fact, if I was not streaming, I probably would not be working on this. Streaming is extremely useful for getting shit done. Like, I could not find my microphone this week. That is why, like, I wasn't streaming or anything. I couldn't find it, and then I finally found it in a drawer in my bed. And, so before then, I just wasn't getting anything done. The most I was getting done was like some small changes on a TUI library I'm making, which I can sidetrack here. Coding, Rust, testing, or TUI GUI examples. So I'm making a Rust library called TUI GUI. It's basically a TUI library that supports animation and shaders and stuff, because I want to make my own fancy text editor. So if I cargo run example Ukrainian flag, for example. Here's a Ukrainian flag. And the reason I did the Ukrainian flag is, one, it is my mother's country of origin, and two, it's a simple thing to make in a TUI library, so, you know. And then I also have an animation example which uses time-based animation, and this is using linear animation. So basically just a lerp function that gets a current duration of how long the animation has been running for, and then it just spits out a value. So if my terminal slows down, the animation just gets choppy. The animation doesn't actually change frequency. Also, the fact that it's time-based means I can control exactly for how long it runs. Here's my shader example, where I can pass shaders to canvases in my library. And that's really all I have so far. So I worked on that a little bit when not streaming, but ultimately it's way easier to get stuff done when streaming. It's like a switch flips in my brain. Like all of a sudden I'm just super productive. SP. So decrementing stack. Store the value on the stack. What? Oh. Okay, so we are... Yeah, you store it at actually SP, so int SP. And then after that, update the stack pointer. Well, okay. Pushed value onto the stack, new SP. Yeah, okay. Get stack contents. Wait. Self.stack. Why is it +1 here? Restoring a value like at ESP. Why are we retrieving the value from ESP +1? Wait, what does this mean? What does that mean? God damn, I'm using so many floating windows. Dang it. EIX, IPython. Ooh. IPython, dev Python, IPython. I'm also going to add this to Rebos so I never have to manually install it again. It's just on all my Gen 2 machines from now on. Dev Python IPython. Let me try building it. Rebos gen commit IPython Rebos list Rebos gen current build. Sudo dispatch -conf. Okay, it's going into ZZZ, that's okay. Rebos gen current build. Also, for those of you who do not know, Rebos is the program that I made that allows me to have reproducibility on any Linux distribution. And yes, reproducibility, not just repeatability. I've had a ton of NixOS fanboys come up to me and be like, actually it's repeatability because you're not repeating package versions and stuff. When actually you could totally just add a package version in Rebos. Like, all Rebos does is pass arguments to whatever package managers you have configured. That's all Rebos does. So you could simply just add the package version in the argument. Thus repeatability. I don't know. I think NixOS people are just sore. They're just sore that I made a program that makes any Linux distribution better than their distro. All jokes aside, though, NixOS is probably superior for things like servers. Because something like Rebos just doesn't cut it when your server has like a meltdown and you need to roll back in Grub. My program cannot do that. My program just basically reproduces what the package managers and stuff does with a simple diffing algorithm. It's more like version control. Like, I can sync my changes to one of my other machines, and the actions it does on that machine would be different from the actions it does on a machine with an older diff, because it's using a diffing algorithm, so yeah. Which means I can also do another floating window. Rebos gen diff, well, Rebos gen list, Rebos gen diff 1 and 27. Here's my diff. Initial setup to 27. Here's my diff. It's a lot of stuff. And I'm going to move this to a new workspace so you can see. Initial setup to IPython. Adding these crates, adding these flat packs, which yes, I do use a lot of flat packs. Adding this to my OpenRC services. I can't remember if this is startup or boot. Initial packages, system packages. So I removed Kuha as a system package, but I added all of this. And oh yeah, so this is OpenRC default, and this is OpenRC boot. So libvirt is in default. And the way you configure Rebos managers is managers. You add TOML files, and it doesn't matter what you name these TOML files. It does not matter, because Rebos has no built-in support for package managers or anything. You actually add the package managers yourself. So like cargo, Flatpak, initial packages is just a thing that I ensure runs before all of them with my manager order.toml. OpenRC, OpenRC boot, and system. So yeah, Rebos, everybody. Manager order. And I guess I just wait for this. Should be done soon. I hope this isn't killing my stream, like the fact that I have something compiling. At least there are plenty of binary packages to speed this up. That's good. But yeah, I still want to figure out what that Python thing means, though. Have you tried DWM? No, and I don't think I want to try DWM. It seems like you have to apply patches for literally every single meaningful thing, and it's also X11, and a conclusion that I have come to after moving to a Wayland compositor is that, wow, I never want to use X11 again. PyCom is a buggy piece of shit. There's no good bars on X11. Like, the best bar you can get is probably either like the Qtile bar or Polybar, and still those bars just absolutely suck. You could use ew as a bar, but ew has no systray, so that's a put off. And also just X11 is slower. I can feel the difference in speed. It's not much on this computer, but I can feel it. But on something like my little laptop, which is $200, it's an HP Stream 11, like Wayland is like at least 5 to 10 times faster on that machine. Why can't you give it up? Oh, you could check out DWL. It's basically DWM, but ported to Wayland. Though, I think all the patches on that are different. I'm not too sure what the situation with that is. What is my CPU usage? H-top. Yeah, I'm fine. I'm fine. This isn't that bad. So, that or I don't know how to read H-top correctly. Which, by the way, I need to... What? Oh. Huh. Low normal kernel guest. Huh. That's cool. The CPU usage also shows me... Wait, what the hell? The CPU usage also shows me what part is like being used by the kernel and what part is being used by normal. That's cool. Configure colors. Broken gray, yeah. Black. Ooh. Whoa. Yeah, I'm gonna choose broken gray. There we go. I need to customize H-top some more. DWL is super buggy. Yeah, I'm not surprised. Python. What is this? I'm trying to understand this, and I need to know what this thing is. My array is equal to I hate Python so much. My array 0, yeah. Okay, so all the values are what you would expect. Now, what is this? Like, what is? Oh. Oh, I see. Okay, so it's getting right. Okay, why didn't I get this before? It's a range. Rust has this too. It's like if I go all the way to 4 or 5, right? Because the range stops before the last number. Then if I go 0, 5, and then I go like 3, 5. Yeah, so it's a range. So I'm getting... Why am I getting the entire stack leading up to ESP? See, this is why you never copy and paste AI code, is sometimes it's just blatantly wrong. I'm also never going to use stuff like Copilot because I have too much respect for open source. So, yeah. Push CPU registers EAX. Yeah, okay. Value register 64-bit. And store the value on the stack. Okay. See, the reason I'm stuck is if I do this right here, then nothing is being stored at BP. It's like the last piece of data would be at address 99, not address 100. I'm going to do something that I've really never done on a stream before. I'm actually going to watch a video. Low level learning. And I'm not going to go to the YouTube homepage because I get a lot of random stuff. And I am kind of concerned what I would get. Videos. Let's see. Stack. The stack. Alright, let's see what he has to say.
Every function you've ever...
Oh, something I also have to do later in the stream is I have to play Conker's Bad Fur Day, Windy Co. That's like a tradition at this point, I think. Well, I'm gonna make it a tradition. I did it the past 2 streams, so I'm gonna do it the 3rd.
Every function you've ever written has had a stack. Well, not this. Hold on. But what is a stack? What does it do for your program? Why does each function have their own? How does it work under the hood? Also, why am I stuck here in Windows XP? I don't know. I'm just as lost in this premise as you are. I got banished here when I coded in Haskell, and I've kind of just been floating around here. Let's go back to the VM.
I love low-level learning.
So here I have a very basic C program that we're going to use to kind of show what the stack does for each program, what a stack frame is, and how essentially a stack frame is used to store local data. Here we have the function main.
Okay, so main function, teehee, I'm in main, int z equals foo x equal, so int x equals 1, so he's creating x variable equal to 1, y variable equal to 2, print I'm in foo, rar xd, return x plus y. Store that back into Z. Okay, this is a very simple C program.
This is the default function in C that always gets called, and by default, any function that you say that isn't a naked function, which isn't, the default attribute isn't.
By the way, can you guys hear this? Can you guys actually hear the video?
Naked, it will create its own stack frame. What does a stack frame do? It creates room for local variables like this function, like this variable z here. Now, when I call function foo, the assembly instructions under the hood are going to create a new stack frame for foo to create room for these local variables. We're going to actually disassemble this program, and we're going to walk step by step through the assembly to talk about how a new stack frame is created. But before we do that, we first need to understand some basic things about CPUs to understand what's going on in the creation of a stack frame. When we talk about assembly in any context, we need to understand that inside the CPU, there are these hyper-fast variables that are called registers. Now, some of them are GP, or general purpose registers, where they can contain any kind of data. One of them is extended BX, EBX, right? We can put any data in there that we want to. It really serves no purpose to the CPU other than general purpose. Now, there are others that are special purpose registers. One of them, for example, is ESP, the extended stack pointer. What that does is that points to the top of our stack frame. We'll talk about what that actually means here in a second. And another one is EBP. This points to the bottom of our stack frame, right? So B being the bottom and S being the top. Now, when we talk about addresses, this is a bit of a holy war in like the computer architecture space. But when we talk about the stack, we can picture a stack of plates, right? So here is the top of our stack of plates, and typically SP will point here. When we push additional variables onto our stack of plates, SP will go up because the top of our stack gets higher as we push additional plates higher and higher onto the stack. Now, it is important to understand that as SP goes up, the value becomes more negative. The more negative SP is, the taller our stack is. I know it's a little bit of a weird nuance in the world of computing, but just understand when we push, SP goes up, meaning SP goes negative. Our stack grows up negatively. And all the while SP is going up in this case, we have BP here, which is keeping track of the bottom of our stack frame. I keep throwing around these words stack frames, so let's talk about what a stack frame actually is. In our example there before, I showed you that we had a function main, and the function main called a function foo. Before function main actually called foo, it already had a stack frame established. So you can kind of picture it like this, where we have two arrows that point to the top and the bottom of the stack, right? This thing here is referred to as main stack frame. And main stack frame contains variables like, maybe it's argc and argv or somewhere on here, right? These are all variables that are in scope relative to main. When I call foo, eventually what we'll go through is the process of the function foo creating a new stack frame that is now above main stack frame. All of these things here will belong to foo and be in local scope for foo. So eventually foo will create this new stack frame, and int x will be there, and int y will be there. These are all local variables to foo, and then when it collapses the stack frame, so that main stack frame is now the stack frame in scope. Okay, so here we go, the moment of truth. On the left over here, we have the assembly.
Okay. Push EBP, push EBP, move ESP into EBP, push EBX. So you're pushing stuff onto the stack, and then subtract 20 from ESP. 14 is hex for 20. And then call and the address, and okay, so add this long hex number to EAX, dword pointer, okay, move 1 into okay, so this is int x, so move 1 into EBP minus 10. Okay, so so 10, so when you see hexadecimal 10, that is in actual base 10, that is 16. Hello ABCD, what up? You're a new face. Hope to see you around more and more. Oh, same, see, I actually see, I think most of you here are a new face. Welcome. Anywho, okay, moving, so, right, okay, so the data does go, like the last byte of data does go into the address at BP. And then C, so A is 10, B is 11, C is 12. So C 12. I'm not gonna do this math too much. Oh. Oh. Harsh. Harsh. You're the guy who always sends, like, crying emojis for some reason. Right? I know a few people who do that. I know there's a few people on Discord I talk to who send a lot of crying emojis for whatever reason. Okay, 12 times 16, 192. So now that I pointed out, right, okay, so EBP minus, that cannot be right. Oh, no, it's EBP minus 12. Right, okay, so push, 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 push. This assembly is a little confusing. Oh. I see. So you didn't actually send it as a crying emoji. I thought like you were sending it because you're super depressed or something.
The instructions for the function foo, and on the right is going to be my drawing of the creation of foo's stack frame. We're going to walk through step by step and explore how these instructions lead to more room being on the stack that are in scope to the function foo, right? It creates room for foo's variables. It can do things with those variables, and eventually we call the function prolog to collapse the stack and get rid of that room and get the stack back to the state that main had it in. So the first instruction we're going to do is we're going to push EBP. So right now BP points to the bottom of main stack frame. We need to preserve that so we can put it back to BP once this function is over. So here we're going to push EBP. This is going to be the old base pointer. Once we do that, we then move ESP into EBP. So that now makes the bottom of the stack equal to the current top of the stack. So now EBP points here. So now we have a new stack frame that is of height 0. So we're going to get rid of this guy. This is no longer here. Both of these arrows.
Okay, so push EBP. Okay, so when you push a value, it sets BP to SP. So SP into BP. Good night, bros. But 23. Assume that's 11 p.m. All right. Have a good night. Good night. Sleep tight. Don't let the bed bugs bite. If you were my brother who loves brain rot, you know what I'd say. I'd say, good night, sleep tight, don't let the Rizzlers bite. He's got problems. My brother loves brain rot. Yeah, it's great to see you in one of my streams. Someone suggested I should do ASMR, but I don't know if that's something I want to do. Like, I guess someone heard me tapping. I was in a Discord call and I was tapping on something and someone was like, oh, you should do ASMR. I think it's this. Something like that. Personally, I watch a lot of ASMR. It helps me sleep. SP into BP, then increment SP by size, or decrement SP by size of int, and then int into SP is that one.
Point here, right? So we have EBP points here as well as ESP. We're then also going to push variables that we want to preserve across variable boundaries. So in this case, we also push EBX. It's going to go on top of EBP. And then after that, we call that sub instruction. Sorry, I had to move my fat head to get out of the way. By subtracting hex 14 from ESP, we raise it and create more room on the stack for foo's local variables. So you can't see it here, but this new area here, this squirrely bracket is the root.
Hold on. Okay, so hex 14, as I've established earlier, is 20 in base 10. So, I'm a little lost here. How big are integer... Oh, okay, so 8 bytes. 8 bytes because 64-bit machine. Or is this 32-bit assembly? Um, hey, can someone in the chat, do you know if this is 32-bit assembly? Yeah. Well, technically it's Gen Alpha stuff. I was actually born at the end of Gen Z, and my brother is born at the beginning of Gen Alpha. So me and Ezra, or me and my brother, are in two different generations. English is my first language, but I still feel weird when I hear it. There's probably feels different if English is your second language. Like, I'll probably visit Russia and then they're saying, I'll visit Russia and they're saying Gen Alpha slang for Russians, and I'll feel weird because like Russian is my second language. What's alpha? Alpha. So alpha male is like the dominant male. Just think about that. So like sigma male, alpha male. Just think about it as like the dominant male. I don't know, it's so stupid. Also, apparently now people say baby Gronk. I have no idea what that means. This is 64-bit assembly, isn't it?
Room for foo's local.
So, okay, EBP and EBX would be 8 bits each, I think. Yeah, it is complicated. I mean, it's not too complicated. Like, for example, I could tell you what all of this means just because I've had the displeasure of having to figure out what all this Gen Alpha slang means. Though I'm not going to do it on the stream because I really do not want to brain rot you all. So, okay, I'll give you one. Phantom tax essentially means to take something away from someone, because the origins is there's a streamer named Phantom and he would take food from another streamer, and it was dubbed the Phantom tax. Stupid stuff like that. ESP. Okay, so what is this 20? Shouldn't it be 16 if you're pushing EBX, EBP, EBX? Okay, then you have 4 bytes left.
Variables. And in our code here before, we had variables x and y. X and y are going to live locally here. And you can see that we actually move the D word pointer of 1 and 2 into these EBP relative locations, right? EBP minus 10, EBP minus C get 1 and 2. That EBP minus 10 and the EBP minus C are the locations on the stack of x and y. So before we talked about the function prolog, right, the area of the function that gets ran before the function even starts, that creates this stack frame for our function foo, and after this happens, foo runs, foo does its logic, maybe it calls other functions, but at the end of foo, we need to actually call foo's function epilogue. What that does is that collapses the stack frame back down so that main can then restore its stack frame to its original state. Now, all the instructions that happen are very simple here. There are 3 instructions. The first is that one that involves EBX. All that's happening here is it's moving the thing at EBP minus 4, which is right here, EBX, it's the old EBX that we pushed, and it's moving that into EBX. So it's essentially taking the saved value and putting it back into the register. This means that main depended on EBX not changing when it called foo, so it told us to push it onto the stack. We did that, and now we're preserving it in the function epilogue. Now what we're doing is now leave is a function in Intel assembly that actually does a bunch of implicit instructions. Intel assembly is basically an interpreted language. It can do a lot of stuff all at the same time. The leave instruction actually moves.
Yeah, most ASMR makes me super uncomfortable too. There are a few ASMR channels that are very subtle about it. Like, they just make comforting noises like tapping and stuff. Those are the kinds of channels that I watch. And even then, those channels, I don't watch most of their videos. I just watch the ones with tons of tapping and scratching and stuff. I don't like the ones where it's like, ooh, I'm gonna kiss the microphone, and then I'm gonna eat the microphone, and then I'm gonna shit out the microphone. Like, that stuff is a little weird, and I do not watch that. So yeah, John Wick, I agree with you.
Moves EBP into ESP. So now ESP no longer points here. ESP points to EBP. It's right here. It's in the same spot as EBP. And then when we call leave, not only do we subtract ESP and put it here, we also pop EBP, which means that the new base pointer is actually down here. So the state of the...
Hold on, so in x86 assembly, when you store and load values into RAM, do they go downward? Like, is the first byte at the pause? Like, is the last byte being stored at the address and then it decrements with every byte? I'm confused now. Let me ask find. Ooh. Ooh, yeah, this might be useful. Fuck you. Fuck you. Fuck you. Fuck you. Ooh. Write example Rust code of push and pop instructions in a CPU emulator. Oh yeah. I'm not surprised. Puberty will do stuff like that. Also, after the Dune movie came out, I started practicing throat singing. Also, because there's a band called The Who, which makes some really awesome. There's a band from Mongolia called The Who. So, like, look them up. The Who. They make some really awesome, like, throat singing music. It's great. I recommend listening to it. And so I started practicing throat singing. So then when people say my voice sounds really high for a 15-year-old, I'll just go, "Are you sure about that?" It sounds worse when I'm sitting. Wait, hold on. Let me stand. Oh. And when I do it for a few minutes, I can also go lower. So I can go maybe like an octave lower when I do it for about, say, 3 minutes. Like it primes my throat or something. I'm not too sure. Okay, push moot self value. Okay, so we're assuming that this is a 16-bit CPU here, I guess. Use std stacks the stack data. Okay, so say this is memory. There's no mention of EBP. There's no mention of BP and SP here. Will this be a problem? I know. I need to... Well, I also just wasn't ready. Like, it sounds way better when I warm up. Which I think is the same with lots of stuff, no? Match instruction, instruction push N. Instruction push N. Yeah, they're not, there's no, it's literally just using stack push and stack pop. That is so cheaty. You little AI, you're clever, but this is not helpful. Please write this example, but using stack pointer registers. This little shit. This is why you never copy and paste AI code. What the fuck is this? What the fuck? My AI answers just went from okay to absolute dog shit.
Stack after this instruction gets ran is EBP points to the bottom of EBP instructions. Intel assembly is basically an interpreted language. It can do a lot of stuff all at the same time. The leave instruction actually moves EBP into ESP. So now ESP no longer points here. ESP points to EBP. It's right here. It's in the same spot as EBP. And then when we call leave, not only do we subtract ESP and put it here, we also pop EBP, which means that the new base pointer is actually down here. So the state of the stack after this instruction gets ran is EBP points to the bottom and ESP points to almost the top. Now there is one more instruction that has to get ran. Now the last instruction we have to run is the return instruction. There is a magical value here on the stack that when main called foo, it got put onto the stack. Now the return instruction is a whole magical instruction. I made an entire other video about the return instruction because it's so complex in how functions call each other. Go watch that video and see if you can figure out what happens next.
It's not all that complex. You just push the instruction pointer onto the stack, and then after you're done calling the function, you just pop it and then jump back to where it was. It's not that complicated. Clickbait. Anywho, Low Level Learning's a great YouTube channel, so I'll cut him some slack. Okay, I need to draw this. Like, I need to... Oh, man. What? Huh? Rebos gen current build. Gen 2, yeah, Rebos force unlock. Yes. Rebos gen current build. There we go. Right, okay. Now I have IPython. And now I can push my Rebos changes. Rebos, CFGS, get status, get add, get commit, cannot type, gen2 IPython. Good. So now all my other Gen2 machines will get those changes. Okay, GIMP. GIMP, GIMP, GIMP. And what I'm gonna do is create a new 32 by 30. Okay, it's gonna be in width 8 and in height 32. And then I'm gonna do some stuff here. Okay, so this is our RAM. Let's say this is the RAM, and right, okay, so I really want to mark stuff down. Okay, so data will be red, I guess. So, okay, SP and BP both point down here. If I want to pop, if I want to push something, moving SP into BP, that doesn't do much, so it's just still pointing down here. And then I subtract the size of the data I'm pushing. I'm subtracting that and putting it back into SP, so SP minus 8. So Badoo, badoo, badoo. And then what I'm doing is I'm moving into at SP, so 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna do 8 bytes here. And so perfect square. This should be a perfect square. Yes, it is. And so the stack pointer, I'm going to use blue for the stack and base pointer. So here is, I am so confused right now. So here's the end of memory, and a memory minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Let me ask Velu. Velu would know. Velu, can you help me? I am trying to understand pushing and popping onto the stack. And I'm gonna send him this. Right, okay, so I subtract the size of the data from, no, I move the value at SP into BP, and then I subtract 8 size of integer from SP, and then I store data at SP. Something I have noticed is that then I have no data being stored at BP. Can you help me understand this? Then I'll send him this. do I do something like this instead, where SP top blue dot is right before the data? Spectrum, do you know? Developing CPUs. It's stuff like this that catches you. It's just you do not know the specific details, and it is super annoying. Oh, by the way, guys, I can send... For those of you who use Discord. SP into BP. Oh, some other people who might know. Cow, do you know? I'm super tempted to just abuse my owner powers to ping everyone, but I'm not gonna do that. Let's see. Who else might know? Oh, Jerry! Jerry. Wrong. Mind. No. Oh, by the way, pregnant man is an emoji. I'm not really sure how I feel about that. So what I'm wondering is... this is so confusing. Let's see if I can get anywhere with AI. Perhaps ChatGPT, because it's trained on a different database. Find is trained on the current web, so... Nah, fuck you, sign-in button. Right, okay. I am trying to implement push and pop instructions in my CPU emulator. I am hitting a very annoying issue where I am confused about the process of pushing and popping. Hi, Jackson122. Feels so weird saying Jackson because that is literally my name. I'm hitting a very annoying issue where I'm confused about the process of pushing and popping. When I set SP to when I decrement SP by the size of the data I am pushing, do I store the data at SP, or do I store the data at SP plus 1? Yeah. Yeah, Jackson. Your cat's name. Something that is a little angering is apparently every time someone looks up the most hated baby name on Google, it turns out to be Jackson, and spelled as in Jackson, which is how mine is spelled. Come on, bro. Google.com, let's see. Most hated baby names. Let's see what we get. Navia. Yeah, I get that one. It's so hard to say. Jaden, Braden, Hayden, Caden, Hunter, Hayden, Bentley. Yeah, come on, bro. What? I mean, at least it's not the most hated name, but why? Why is my name here? Come on. Michael. Dude, this is my dad's name. What the fuck? So this is my dad's name, and this is my name. Come on. Why? Why? Oh, man. Michaela? Yeah, I don't like that name. Hope. Oh, that's funny. Mackenzie. McKenna. Addison. Gertrude. It makes sense that Gertrude is in this list. It does sound like a rotten fruit or something. I'm not sure. Caitlin. For its made up spelling, yeah. Yeah. Bertha. Bertha's not that bad, is it? Hunter. Too much like the last name. Like a last name or too violent. No. Okay, sure. Let's see what the other list has. Yeah, it's the same. You know what might be like Michael and Jackson? It could be because it sounds like you're naming your baby after Michael Jackson. No, block. Fuck you. I don't want you to know my location. Okay. SP. So you're storing... Okay. Yeah, Michael Jackson. In a typical CPU architecture, the stack pointer, often denoted as SP, points to the top of the stack. When implementing the push and pop instructions, the general convention is push operation. Decrement the stack pointer by the size of the data you're pushing. Store the data at the address pointed to by the updated stack pointer. Here's a step-by-step process. Decrement the stack pointer if the stack pointer SP is currently pointing to the address and you're pushing a 4-byte value, for example, you would decrement SP by 4. So SP would now be... Okay, so... Right, okay. And then 0FFC. Okay, yeah, so... Okay, that makes sense. So you're just decrementing the stack pointer by 4. And then... So SP would now be... Yeah, so it's basically just this minus 4. That's what this is. Store the data. You then store the data at the address SP, which is now 0FFC. For instance, if you're pushing the value this onto the stack, you would do... Oh yeah, source art, yeah. Well, yeah, I saw that, but, you know. It's still the 2 top results. Come on, bro. Come on. Why do you have to throw shade on my name like that? SP. SP equals SP minus 4 memory SP. Okay, so you're storing stuff at SP. Pop operation. Load the data from the address pointed to by a stack pointer. Increment the stack pointer by the size of your data that's popped. Okay. Here's a step-by-step process. Load the data, read the data from the address pointed to by SP. Increment. Load the data, read the SP, increment the stack pointer after loading by the size of data for you popped if instance. Yeah, that makes sense. So if you're incrementing SP by the if you're decrementing SP by the size of the data you're pushing, you should store the data at SP points to after the decrement. This is a common pattern in stack-based operations and helps maintain a last in, first out order for stack operations. I feel like ChatGPT just gave me better results. Right, okay, so let me go back to GIMP. So, base pointer. Okay, so I think I understand. SP points at the data, and then BP points to after the data. So then so let's say I pop. Let me bring up my little thing here. Let's say I pop. So I move SP into BP. So BP would move up here. So, BP is now here. And then I'll make BP a different color. BP will be purple. So, no, that's not good. BP will be gold. BP is now gold. Okay, so BP is now BP is now where SP is. And then I'm decrementing SP by, say I'm storing a 2-byte value onto the stack. I decrement SP by 2, so SP minus 1, SP minus 2. So there, and then and let's say this new stack data is a different shade of red. So here is the data that was just pushed. Okay, so yeah, base pointer would just point to the data plus 1. So I guess there's a byte here in RAM that's wasted, I guess. Okay. So let me just verify with the AI. So does BP come into play at all? Jackson, or the Skippy fan. What I'm doing is I'm trying to figure out stack operations. So like I'm trying to make it so you can actually push and pop values on the stack. Which is essentially like when you call function in programming, it pushes stuff onto the stack, like local variables and stuff. So that's what I'm trying to implement into my CPU so then I can finish emulation. Because the emulator, it works, but if you try and do like a push or a pop instruction or a return or call instruction, it's gonna crash the emulator, say, to do, implement calling subroutines or something like that. So I need to actually implement all that stuff. So now I just ask about, oh, welcome. So, move SP into BP. Wait, I just realized maybe BP has nothing to do with this. That would make sense. That would make a lot of sense that BP has absolutely nothing to do with this. So, yeah, okay. So, push. Right, okay, so push int into SP. So let me just delete the base pointer here to see how this would work. So let me do this again. So subtracting SP by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Something's not right here. Okay, so subtract by size of int. So subtract by 0, by 1, by 2, by 3, by... I'm just gonna reset this entire thing here. So subtract it by... Felipe Avelar. What do you... Oh, you mean the chat. Oh, yeah. So the chat here is actually a separate window. That's why it wasn't on the Discord thing. It's because I was just going to the Discord thing momentarily, so I didn't bother with moving the chat there and then resizing it and stuff. Okay, so... 0, 1, 2, 3, 4, 5, 6, 7, 8. So now the stack pointer is here, and I will delete this. And now if I store an integer, so... Wait, you can only see the Discord screen? Oh, shit! Did the stream just freeze? Oh, that's not good. Oh my god, what the fuck? That's not good. What? Why is this happening? That's really weird. I do not want to end the stream, but I might have to. Oh my god. Okay, I'm gonna stop streaming. And then I'm gonna start a part 2 or wait, or did that fix it? No, it's still frozen. What the heck? Alright, here's what I'm gonna do. I'm gonna stop streaming and then I'm gonna reboot and try.